Okay, so section 2.4, exact equations. A differential expression mxy dx plus nxy dy is an exact differential equation if this is the truth. If I ask you to solve the differential equation using exact method, then you need to go through these four different steps. You need to identify M and N and find C that is exact or not. And then you need to partial derivative of one in terms of X or in terms of Y. And then find the partial derivative of the other one. And then compare, find the G of Y. Those are the four steps. So basically you have an option as a second step. You're going to take the partial derivative of x or y. So you are given 2xy dx plus x squared minus 1 dy equals to 0. In front of dx, we're going to let that equal to m. So it's basically alphabetical order. So x before y, and we have m before n in front of dy. It's gonna be n. Then what you need to do for m, we're gonna do the differential in terms of y. For n, in terms of x. So for m in terms of y, that is 2x. When we do differentiate in terms of y, x, we can consider that as a constant, right? So 2x. And then for n, can take the derivative in terms of x, it's gonna be 2x. So now they are the same. That means this is exact differential equation. Step number 2, find f x comma y using partial derivative in terms of x. Means we're gonna say equals to m, and we said m equals to what? 2xy. So from here, we need to find f. So we need to take the integral in terms of x. We have 2y, those are the constants, and then x dx. So we have 2y, 1 over 2, x squared, plus g of y. Because all the y terms, we treat it as a constant, so it's going to disappear. So we need to put y right there. And basically, this is our answer. After we find g of y, right? We need to find the g of y. Step number 3. This is our f x comma y now. And then we're going to take derivative in terms of y for this guy. I'm going to write the equation here one more time. So 2 and 2 is going to go away. Y x squared plus g of y. That is fx comma y. We're going to do the differentiate this guy in terms of y. So the first term is going to be just x squared. Second term is going to be g prime of y. Step number 4. So now we have this as g prime of y. Now we need to compare with n, which is x squared minus 1. When you compare this, we now know g prime of y equals to -1. And from here, g of y equals to -y plus c. So we said we have this as an answer. So x squared y plus g prime of y. We said the answer x squared of y plus g of y. Now we said g of y equals x squared y minus y plus c equals to 0. So that's the answer. Just real quick, we had 2xy dx plus x squared minus 1 dy equals to 0. We just use the exact technique. Let's review first two techniques using this equation. So the first, we said in section 2.2, we use separable. Is it separable? Let's see. So we have 2xy dx x squared plus 1 dy. So we're going to divide x squared minus 1 for both sides. Then we have 2xy over x squared minus 1 dx equals negative dy. And you're going to divide both sides by y. We have 2x over x squared minus 1 dx equals negative 1 over y dy. So it is a separable. Now we need to take the integral for both sides to get the answer, right? So it is a separable, and take the integral for both sides. And the left-hand side, we have a square term at the denominator. So I'm going to let x squared minus 1 as a p. Then 2x dx equals to dp. Then integral 1 over p dp, right? 2x dx, they all become dp. Left-hand side is going to be ln p, and then right-hand side, negative ln y plus c. And we take the e for both sides. Then we have p in this here, y to the negative 1 times e to the c, because we're going to take this negative to the power. Then the p we set x squared minus 1 equals 1 over y e to the c. And we're going to multiply y for both sides. X squared y minus y equals c1. And we said x squared minus 1 has to be greater than 0. And y has to be greater than 0. So they are the same. Okay. We just did the problem using exact method. And we have the same answer here. And then 2.3, is it linear? Right, so that we can use the integrating factor. So again, 2xy dx plus x squared minus 1 dy equals to 0. So we need to have a dy over dx. So divide everything by dx first. So 2xy plus x squared minus 1 dy over dx equals to 0. And this is not the standard form. So we're going to divide everywhere by x squared minus 1. Then we have dy over dx plus 2x over x squared minus 1 times y equals to 0. And this is linear. Now, we need to find the integrating factor, right? 2x over x squared minus 1 dx. And we know integral 2x over x squared minus 1 from here, e to the integral 1 over p dp. So that is int e ln p, that is just p, which is x squared minus 1. That's the integrating factor. And then we're going to multiply this integrating factor to everywhere. Dy over dx times x squared minus 1 plus 2x over x squared minus 1 times y times x squared minus 1 equals to 0. And all of this is d over dx y times x squared minus 1. So take the integral for both sides. Yx squared minus y equals to c. That's the same answer. So we quickly review first two techniques, separable technique and the linear technique for this problem. Problem 2.4.2, and you're given 2x plus y times dx minus x plus 6y dy. And you're going to let the first as a m, second one as a n and take the partial derivative for the m for y. We got 1 for partial derivative in terms of x for n. We got -1. They are not the same. Therefore, this is not exact. So by looking at it, this is not separable because y and x, and this is not the linear, so y is everywhere. So in this case, we need to solve this using substitution, which is the next section. The number 1, m equals e to the 2y minus y cosine xy. Now we have n equals 2x e to the 2y minus x cosine xy plus 2y. From here to my, take the partial derivative in terms of y. So first one, 2 e to the 2y times derivative of 2y, which is 2. So 2 times e to the 2y. And we have two terms, y and y here. So the first derivative, which is 1, and second, and minus first, second derivative. So cosine is going to be negative sine x times y. And then times inside of the parenthesis, it's going to be x. So that is 2 times e to the 2y minus cosine xy, and then plus y times x times sine xy. And from here, we need to do nx. We have only one x, the first term. So we have 2 e to the 2y. And we have a 2x's right here. So the first derivative, second one, minus first and second derivative, cosine is going to be negative sine xy, and times we have a y. So that is 2 e to the 2y minus cosine xy plus x and y and sine xy. So they are the same. So it is exact. That's the first step. Then number 2, we have a choice, either partial derivative of in terms of x equals to m. That's what we did in the first problem. The second choice we could do is partial derivative in terms of y equals to n. Just for this problem, we're going to do this. Now we need to find fx comma y, which is integral of the n. Then 2x is the constant, and e to the 2y dy. And then minus x is the constant, integral cosine xy dy. Plus 2 is the constant, y dy. We have 2x times 1 over 2 e to the 2y, and minus x times 1 over x times sine xy plus 2 times 1 over 2 y squared, and then h of x. So this, so we have that. We're going to let this as our answer. Now we need to find h of x.
Let's simplify a little bit. 2 and 2, x and x, 2 and 2. So we have x times e to the 2y minus sine xy plus y squared plus h of x.
Now to find h of x, we need to take the partial derivative of this guy in terms of x. Then we have e to the 2y and minus y cosine xy. And this guy is just a constant, so it's going to disappear, or 0, and plus h prime of x. Now we need to compare this guy with m, and we have m as e to the 2y minus y cosine xy. So we compare, we have that, we have that. So h prime of x equals to 0, h of x equals to just c. So the answer is going to be e to the 2y minus sine xy plus y squared equals to c. M equals sine y minus y sine x. From here, m in terms of y, my equals cosine y minus sine x, and we have n cosine x plus x cosine y minus y in terms of x, cosine to sine, negative sine x plus cosine y, and this guy is going to be 0. So they are the same. It is exact. Step number 2, partial derivative in terms of x equals to m, that is sine y minus y sine x, and find fx comma y, that is integral m dx equals sine y integral dx minus y integral sine x dx, that is sine y times x, and then minus y times minus cosine x plus g of y. So that is x sine y plus y cosine x plus g of y. It's going to be our answer. And step 3, to do partial derivative in terms of y, and that is x times cosine y plus cosine x plus g prime of y. Now we need to compare with n, and we have n right here, and now we know g prime of y equals to negative y. That means g of y equals negative 1 over 2 y squared. Then answer is going to be x times sine y plus y times cosine x minus 1 over 2 y squared. I forgot to put c there. So you can say equals to c or plus c equals to 0. Really doesn't matter. So 2.18 and 2.422, they both are on YouTube. So please try yourself first and check for the answer.